Appreciate the introduction, and I appreciate the invitation to present to ACON. So I'm looking forward to talking about Transcend Air and what we're trying to do. I am virtually sitting in the cabin of our Vy400R. That's the reserved edition, the VIP edition of our VTOL aircraft. And so let me dive in, share my screen, and tell you about the Vy400 and what we're doing here. So as you can see, the title of my presentation is the Vy400, VTOL Now, E When Ready. So what does that mean? Well, you guys may well have heard, because there's been a huge burst of publicity over the past few years about electric VTOL aircraft, or E-VTOL aircraft. And some of the leading names based on their funding to date are Volocopter, Archer, Lilium, and Joby. So I put this graphic together to kind of show you the difference between what their aircraft designs are being stated is capable of doing and what ours can do. So on the near axis, we have the distance, that's the range of the aircraft. And then on this axis, you have speed. And so you can see the Volocopter, which is an 18-rotor multi-copter drone-based aircraft, can only go 22 miles at 70 miles an hour. So that's this little dark orange slice. Archer, which came out of stealth mode earlier this year, has an aircraft that can go 60 miles at 150 miles an hour. So Lilium is claiming 155 miles at 175 miles an hour. And then there's Joby, who say they can go 150 miles at 200 miles an hour. So, you know, these are limited range aircraft, and that's because they are trying to be all electric powered. Meanwhile, our aircraft, which uses a turboshaft jet engine, will take you 500 miles at 400 miles an hour or more. So we like to say that the Vy400 is using proven technology to build a disruptive aircraft. And disruptive of what? Well, disruptive in entrepreneurial terms. Disruptive of existing markets. So we're going after fast, convenient, affordable regional air mobility. So what does fast mean? Well, 405 miles an hour, 352 knots, 652 kph in airplane mode with the wing tilted down. Convenient? Well, one of the key things I learned at Linear Air is activating travel demand on aircraft at this scale using reliever airports is really challenging. We tried very hard. And what it comes down to is there just aren't enough people living around any given reliever airport to let you fill the seats, offer a dead schedule, and keep them full. VTOL is the key to unlocking the center of cities. We can operate out of city centers, and there's obviously that's where all the people are. It's like what Willie Sutton said when they asked him, why do you rob banks? He's like, well, that's where the money is. So why do we want to use VTOL to serve city centers? It's where the business travel demand is to start out with. And then affordable. Surprisingly, since we're all used to jet-powered aircraft, especially small ones at this scale that look cool, being expensive, it turns out that taking advantage of the VTOL architecture and going fast, we can use with a similar sized aircraft with one turbine to a Bell 407, we can cut the per mile direct operating costs 50% versus a Bell 407. And I'll talk some more about that. But even more importantly, affordable, we've designed a regional airline that will let us offer a $283 one-way ticket on average between Boston and New York, which I want to point out is less than taking an Uber to the airport, the Delta shuttle to LaGuardia, and an Uber to Manhattan. So that's what really gets me out of bed in the morning, is that this is going to be a mass market service that is going to be really nice. Some key facts about the aircraft: it's single pilot operation. Has 5 passenger seats, so 6 places total. We use variable pitch propellers, but not constant speed in the usual way. They are, in fact, constant speed, but turns out that changing the pitch of the propellers in ways different from how a turboprop works is important to managing transition. It is a tilt-wing aircraft. I know it looks kind of like a mini V-22, and I'll explain the difference, but it avoids the V-22 tilt-rotor complexity trap, which is very important to us. Has a single engine. So again, you see 2 propellers, you think it's a twin. Nope, it's a single. We use a mechanical gear train to drive those 2 propellers. It has a BRS, ballistic parachute system, so same as the Cirruses. And then you see an electric tail fan at the rear, which we use to give it pitch authority in the hover and helicopter mode. So that's some of the basics at a high level. Let me dive in here. So I'm assuming you have, in fact, heard about these E-VTOLs. If you haven't, then my apologies for these next couple slides. But I've learned from talking about our aircraft over the past several years that everybody has a lot of built-in assumptions from what they've heard about E-VTOLs, and I need to deprogram you from those assumptions in order for you to appreciate this aircraft. So this is a projection of battery capacity based on historical trends. So in the second half of the 20th century, batteries grew at 3% a year. That's the red line. When lithium-ion batteries first came out, there was a decade where they grew at 8% a year. That's the yellow line. And then there was a period where NiCad batteries grew at 5% a year. So depending on which growth curve you want to project for where we are today into the future, you get different time frames before batteries are good enough that you could fly a high-speed mission with them and get some range. And that's approximately 1,000 watt-hours per kilogram, that green line there. So you see it's 2041 until batteries will be good enough where we might consider an all-electric Vy400. So our position is that we don't want to wait 20 years. We've got an aircraft design we can build now, we can start selling now. So our position is sell aircraft now, electrify later. And if you look at our business projections, we project that we can sell $58 billion worth of Vys in the next 20 years. That's the actual marketing and unit shipments ramp-up graph there overlaid on the battery graph. So we're not willing to wait for batteries to get good enough for our city-to-city mission. So I mentioned that it looks kind of like a V-22. So how does it compare to tilt rotors? Tilt rotors are the only VTOL aircraft that are flying right now, and it's only the V-22 is the only one that's in service. I mean, the only VTOL ones that are not turbojet powered, not counting the Harrier and the F-35, or helicopters for that matter. So what about tilt rotors? Well, they're complex. If you look in the lower right-hand corner now, you see that's a helicopter rotor head. If you count the parts in that helicopter rotor head and compare that to a variable pitch propeller, there's more than 10 times as many mechanical parts in that rotor head. Whirling around, spinning, twisting, leading, lagging, flapping, you name it, in order to make a helicopter work. And what the V-22 is two helicopters that they've yoked together and made tilt sideways. It's a miracle of engineering that it works at all. But because of that complexity, it's expensive to operate, it was expensive to develop, and it doesn't have a great dispatch reliability and service. It's not where the Marines would really like it. And what's the expense? Well, those are $71 million aircraft. And these drawings are all to scale, by the way, just to give you a sense of the very big scale. Bell is in flight test with the V-280 Valor, which they have aimed at a new Army program. That's going to be a $30 to $50 million aircraft. It's a 33,000 pound gross weight. The V-22 is in the 50,000 pounds class. Then we get the Augusta-Westland AW609. If its fuselage looks familiar, it was deliberately designed to be like a King Air. They sort of saw it as a tilt rotor King Air. That's going to be a $24 million aircraft. It's been under development for almost 20 years now, or maybe over 20 years. And again, it's just these things are wicked complicated. Meanwhile, our design comes in in airliner trim. That's what this blue and white livery means, at a price of about $3.5 million. So our design targets have been simplicity, reliability, maintainability, interoperability. That's one of the benefits of using Jet A instead of electricity. Affordability, adaptability, and upgradability. And what do I mean by upgradability? Well, the good news is, in that great and glorious day when batteries achieve a sufficient power and energy density, we will be able to take the turbine out of the aircraft here, just behind the wing. We'll be able to take the fuel tank out, right here at the CG, replace the turbine with big electric motors, replace the fuel tank with batteries, and existing aircraft will become all electric. So, I mean, we do believe and agree that the eventual future of aviation is electric, but we think people are trying to build all electric aircraft right now are jumping the gun and are going to regret it. And we're not the only ones who agree with that. Abbott Aerospace Canada, which is a very well-respected aerospace consulting firm, analyzed 220 aerial urban mobility designs, so including Joby and Lilium and the other ones on that slide, and us. And they ranked us number one. So we're very pleased that other aerospace pros understand the value of what we're doing and why. And in fact, we've attracted an amazing team to the program. And it's all because when we talk to people who actually are familiar with aircraft manufacturing and real aerospace programs, they get why we've made the choices we do, agree with it, and then they want to be a part of it. So we've been very fortunate that way. So what is our mission? Our mission is to target already proven markets with a low-risk, high technology readiness level design. All right, TRL is a NASA acronym. They have a standardized ranking, and it goes from 1 to 9. And the higher you are on a TRL ranking, the less technology risk there is in that part, that subsystem, or your aircraft. So we've designed an aircraft that's going to fill 2 proven market needs: VIP, rotorcraft transportation, and regional airline needs. We've worked very hard with our team of advisors and employees and consultants to make sure that this aircraft is both manufacturable and certifiable. It's going to be profitable for the manufacturer. It's going to be profitable for the operator. You'll see when I show you some more of the interior, it's going to be liked and trusted by passengers. And ultimately, what's most important is it's going to enable lower prices for aircraft and fares on the airline. This business part is not specifically about the aircraft itself, but the reason it's so important is that this is where Greg and I, my co-founder, started with Transcend. Some of you may be familiar with the Eclipse Very Light Jet and the Very Light Jet bubble of the mid-2000s. I joined Linear Air picking up the pieces. Linear Air was the last independent operator of the Eclipse 500 standing back in 2010 when I joined. And the promise of the Very Light Jet age was based on NASA's small aircraft transportation system concept, which sounds great. You could walk up to Hanscom or Beverly or Norwood or any reliever airport, and there'd be this really sophisticated twin jet sitting there waiting for you, all warm and ready to go, and you could fly off to wherever you want, and it would be inexpensive and affordable. Well, I spent 5 years at Linear Air proving that that's impossible. And that's one of the reasons why we're not interested in the urban air mobility application that the E-VTOL aircraft are targeting, because that's just a single city variant of this same problem. And I'm not here to talk about that in detail tonight, but what I am here is to try and explain to you guys, we had to find a business model where there'd be enough demand for the aircraft that it would be worth us quitting our day jobs and developing a whole new aircraft certification. And that's what this already proven markets is about. And that's what using proven technology is about. It's to contain the certification risk and know you're going to be able to sell aircraft and sell seats on aircraft afterwards. So Greg's quote here, it's a mistake to bet your success on future technology developed by someone else, right? We've got all the eVTOL companies betting their success on unknown when it's going to happen battery improvements. We saw that with the Very Light Jet bubble. Eclipse, their number one order set came from a company called Dayjet, which was another startup by Ed Yakabuchi. And his claim was that fancy math and software would let you optimize your fleet movements and make money. Well, it turns out it doesn't. There aren't enough people around these reliever airports to fill your seats, and so you're not going to be able to fill them, and then you won't make money, and it doesn't matter how fancy your math is. And I hear people nowadays, the vogue term is to say, well, we'll use AI. Well, no amount of AI and algorithms, and I say this as a guy who has an MIT computer science degree, is going to change the fact that there aren't nearly as many people living around Hanscom as there are around Logan. So you can't run a schedule. And that's my quote. I learned the hard way. If you haven't ever sold air travel, there are lots of reasonable sounding arguments about why people should buy it that turn out not to be true. And so my tenure at Linear Air was really just a succession of testing those and finding out they weren't actually true, sadly. So our program will succeed because there are 3 aircraft markets. 2 are already proven, the VIP helicopter disruption and regional airline service. And again, this is why we did it, and I'm motivating it to you because I want to give you hope that this cool aircraft will actually make it through certification into market, and you'll get to fly in it. So the simple math on our aircraft is it is half the acquisition price, 3 times the speed, and 1/4 the operating costs of a medium twin executive helicopter. So that's a 24x value increment, which is why we're going to disrupt the VIP helicopter market. So we think of the Vi as the world's fastest helicopter. And why is that? Well, there's no free lunches in engineering, and especially not in aircraft engineering. You've got to make trade-offs. And so the Vi has some real advantages. It's high speed. It's the highest speed aircraft on this list. It's faster than the King Air. It's faster than the Pilatus. and it's got cabin volume. It has nice big cabin volume. It has similar cabin volume to the King Air, not as much as the Pilatus, that's the King. More than the Sikorsky S-76, a little bit less than the Leonardo AW139, and hugely more than the single-engine helicopters, 61 cubic feet and 84. I mean, the Vy is at 252. So what's our trade? Well, look at the range. In executive trim, as you see here with the big fuel tank, and with just a pilot and one passenger, it'll be able to go 550 miles with appropriate reserves. You look at the other helicopters, and they're like, nearly 400, a little over 400 for the Sikorsky. So we're comparable to that, maybe a little bit better. Then you look at the Pilatus, over 2,000 miles. All right. So somebody who buys a Pilatus wants that range, and they're not going to buy a Vy instead, even though it's faster. We don't have the luggage carrying capacity, and we don't have the range. So we don't expect to really compete with fixed-wing turboprops at all. But we do expect to eat the lunch of these turbine helicopters, because in executive trim we're more than these list prices for the Bell and Airbus, but those are in standard trim. If you do executive trim on those, you get something that's going to end up similarly priced. And meanwhile, we're half the price of the executive helicopters, and the main reason for that is those are twins. They've got two engines that are similar to what we run just one of. And they need to for safety, because if they lose one engine, they want to be able to make an emergency landing on the remaining one, running at extra high power. We rely on the parachute for that. So you can see how all the aspects of the design come together to yield the benefits we're going after. And Keith, I'm not monitoring the chat, so if there are any questions at this point, I thought maybe I could pause for a second.
No, you're doing such a great job right now with providing information that we don't have any questions just yet, but people should enter them in the chat if they're interested.
Yeah, if anything comes up, please do. So it's not just us that think that it's great, or Avid Aerospace that think the design is great. I'm pleased to say that we also won an award from the Robb Report, which is a luxury publishing empire, if you're not familiar. So we were awarded Best of the Best for VTOL concept for the Vy400R Reserved Edition. That's the VIP model. It also stands for Racing Inspired. You can see the polished carbon fiber interior in here. And one of the things I really want to highlight as an aircraft features, one of the benefits of the wing is cabin volume. So if you look at our club seating configuration, if David and I sat opposite each other in those seats and stretched our legs out, we wouldn't even be able to touch toes. And you compare that to the Best of the Best winner for helicopter, which was this beautiful Airbus ACH-130, the Aston Martin edition. And it has the same number of seats, by the way. It's a single-engine turbine. But look at the legroom. I mean, that's worse than an airliner. That's the problem with helicopters, especially smaller ones. You have to fit all the mass underneath the rotor disc, and so you end up with no legroom. So for about the same price as this ACH-130, you can go 3 times faster with half the per mile operating costs and that kind of legroom. You can see why we're pretty bullish about disrupting the market. But what about this airline service I'm talking about? One of the questions that I get asked fairly frequently is, if this regional VTOL airline service is such a good idea, how come people don't do it with helicopters? Well, the reason is it's too expensive to do it with helicopters. And the reason it's too expensive to do it with helicopters is because they're slow. So I was talking about per mile operating costs. The Vy does the trip from Boston to New York in about 36 minutes. In a Bell 407, it's nearly an hour and a half, right? So even though the Bell burns less fuel per hour than the Vy does, the fact that it's so much slower means to accomplish the trip, it burns more than twice as much fuel. It puts more than twice as much wear on its engine. And so the DOC per mile is twice as high. And when you flow that through a typical Part 135 cost structure and pricing structure, which is what I've done in this example, I'm assuming all of these aircraft are being operated Part 135 commuter on a scheduled service. When you flow that all through, the ticket price you can charge ends up being up around $600. Another thing that hits you is that with an aircraft as fast as the Vy, or even the Cessna and the Pilatus, you can run 4 round trips per day between Boston and New York. And you have to use 2 shifts of contract crew to do it, by the way, based on rest and duty regs for your ATP pilots or your commercial pilots. but you can get 4 round trips. The helicopters are slow enough that you can only get 3. And that missing that 4th round trip per day means that you're amortizing these ticket prices over lower capital utilization. So in business terms, it's just less efficient aircraft, and that ups your prices. So you'll see that the VY falls between an airline at 7 days advance purchase and an airline at 2 days advance purchase. So we are down in the considered set. Your CFO would likely accept an expense report for our ticket price for a business trip. But what I learned at Linear Air, much to my chagrin and to dashing the hopes of people who think that a 60% reduction in operating costs means cracking open a big market. If your price is not lower than the airlines, they will not fly on you. There's no mass market at prices higher than the airline fares. And the reason for that is, unlike us pilots and aircraft fanatics, travelers only care about what they're going to do at their destination. They don't care about the aircraft. And the people paying their travel bills only care about minimizing that expense. So, I had a real life example where a friend of mine needed to do a pop-up trip to Montreal, he and another person from his company, and chartering a Linear Air Eclipse jet was actually less money than the last minute fares on Air Canada. And his company would not let him pay Linear Air less money than flying on Air Canada because they had such a strict no flying private policy. So they spent more money in order to protect their what they saw as a critical expense saving policy for them. These aircraft, the King Air, the Pilatus, and the Cessna, one of the reasons they're more expensive, I mentioned, is that they have to use airports. And what's the disadvantage of using an airport? Well, in the case of our travel model, which is downtown to downtown, it's actually a pretty significant price to take an Uber out to a reliever airport or from a reliever airport into the city. So there are certainly cases where, if you lived near Hanscom and you had a meeting near White Plains or Teterboro, then in that case, a caravan would be cheaper than the VY, right? Because your ground transportation cost wouldn't be amortized in. What I'm showing here is door-to-door time and door-to-door cost, including ground transportation. So, there are certainly trip classes where the VY would be more expensive. But on average, for the big bulk of travelers in the center of the city, we're going to win. Now, our design comes from a legacy of 16 flying prototypes that dates all the way back to the first napkin drawing, and there it is in 2009. Prior to co-founding Transcend Air with me, Greg, my CEO, he quit his day job and joined a guy named Oliver Garrow. Oliver is a VTOL inventor, and Greg saw some of these prototypes that Oliver had already developed and flown. He convinced Oliver to quit his day job, and they together built a 2,000-pound manned prototype aircraft, which is this one right here. So this is a 2,000-pound experimental. It's a tilt wing, 2 props, like the VY, but you'll see it has this box wing or Prandtl wing wrapped around it. And that design dates all the way back to Proto 8 here in 2013. So you see Proto 8 has the central tilt wing and the box wing around it. This is a 1/5 scale prototype aircraft, but that performed so well, that's what convinced Greg to partner with Oliver and fund the development of that 2,000-pound manned aircraft. And so this lineage of prototypes has been hugely educational and influential in our aircraft design. You can learn a lot from simulation, you can learn a lot from analysis, but you have to fly in order to see where reality really is. And with this lineage, I can say that the VY design benefits from the reality of flying more different types of electric VTOL aircraft than I think anyone else in the world, including NASA, by the way. So again, that's another reason why we're confident that we've got a real winner of a design here. And I should stress again, all of those on this page are electric aircraft. Our current 5th scale prototypes are electric. And as David said in my intro, I'm the chair of the Electric Flight Test Committee of the E-VTOL Flight Test Council because we are actively flying electric aircraft now. It's convenient at the 5th scale to do that. So we know very well why electric aircraft limitations are strong right now, and that's why we're sticking to a turbine. So here's some examples of the 5th scale, and you can see some of our telemetry data from while it's out flying. And down in the lower left here, that's our Chief Software Officer, Bob Schulman, with one of the fifth scale prototypes up at ICAO headquarters in Montreal. We were invited to present at their innovation forum, which was really cool. Over here in the upper right, you can see a parachute test. Our fifth scale has a parachute, just like the full scale, and for similar reasons, for safety. These aircraft are pretty big. They're small UASs, which means they weigh just under 55 pounds. And that's a lot to come falling from the sky if there's a malfunction. So we have this parachute on there, and it'll be automatically deployed if the aircraft goes out of control, and we can manually deploy with a radio signal. It uses, the Cirrus parachute uses a rocket to deploy it. We use a compressed CO2 canister that blows the packed parachute out of its container. So what that white puff is a puff of carbon dioxide smoke, and there's actually a little bit of bits of carbon dioxide snow flying out of there too, which I thought was kind of cool. And there's me standing with the two flying prototypes together. So again, we've learned a lot here, and we iterate through flight test, truck-based wind tunnel testing, X-plane flight simulation, and all sorts of analytical tools. And we don't believe one technique by itself, and it's not until we put something in the air that we really believe we have something.